Hello everyone and welcome to the class of sensitivity analysis. In the previous video we did a sum and now we'll do some more sums based on that particular table. Today's sum. In the last sum, determine whether the current basis remains optimal in each of the following cases. Case number 1. Raw materials M2 reduced to 105 kg and labor F2 increased to 145 hours. And number 2, supply of raw materials of M2 increased to 122 kg and labor F2 supply reduced to 78 kgs. Sorry, it will be 78 hours. Supply of raw materials M2 increased to 122 kg and F2, that is the labor's supply, reduced to 78 hours. Hence, we find the solution. For both, number 1, both the RHS values change within their respective allowable range and hence there is no change in the current basis, that is optimal. For case 2, that was for case 1, and now for case 2, the raw material supply of M2 is within allowable range while the labor supply has reduced by more than allowable decrease, hence the current basis is no longer optimal. Hence, here basis will be unchanged and in the second case basis is no longer optimal. Now let us apply the 100% rule which we learned in the first video to apply here to seek the desired answer. Now let us apply the 100% rule and let Bi be the current RHS value of the ith constant. Let del Bi be equal to the change in the RHS value of the ith constant, that is new Bi minus given Bi value. And let capital II be equal to the maximum allowable increase in RHS of Bi for which the current basis remains unchanged. For which the basis remains unchanged and Di is equal to the maximum allowable decrease in RHS of Bi for which the current basis is unchanged. for which the basis remains unchanged. Hence, now we know that the ratio Ri is equal to del Bi by capital II. If del Bi is greater than 0, else if del Bi is less than 0, therefore Ri is equal to negative of del Bi by di. Now if del Bi is equal to 0, that there is no change in Bi, then Ri is equal to 0. Now if one of the constants is changed, then the current basis remains optimal. If Ri is less than 1, that is. But if Ri is greater than 1, then we may not be sure whether the current basis would remain optimal or not. Now students, we will do some more problems using the formulas which we derived in the above. Considering the same problem with the same data, examine whether the current basis remains optimal or not in each of the following cases. Case number 1 is availability of M1 is 82 kgs and availability of F1 is 69 hours. Of M1 is 82 kgs, availability of F1 is 69 hours, and case 2 says that availability of M1 is equal to 96 kgs, M2 is 97 kgs, F1 is 64 hours, and F2 is 115 hours. Now the solution of the first case. First we will solve the first case where B1 is equal to 82 minus 90, which is equal to minus 8. D1 is equal to 30. Therefore there R1 is equal to 8 by 30, which is equal to 0.267. Now B3 is equal to 69 minus 60, which is equal to 9. I3 is equal to 150 by 11, that is 11. Therefore we find that R3 is equal to 9 by 150 further divided by 11, that is equivalent to 0.660. Hence summation of Ri is equal to R1 plus R2 plus R3 plus R4, that is equal to 0.267 plus 0 plus 0.660 plus 0, that is on adding we get 0.927, which is less than 1. Therefore their summation of Ri is less than 1. Hence the current optimal basis will not change. However, although the basis does not change, the objective function value of z will change as the RHS value of the constants change. Basis not changing, but objective function is changing. Now we know that the del J values of S1 is equal to minus 35 by 6 and del J values of S3 is equal to minus 125 by 6. Hence the net change in the ZJ value is calculated as follows. Now decrease in M1 8 kg at 35/6. The change in profit is 8 into minus 35/6, which is equal to minus 46.67. Similarly, increase in F1, that is 9 hours at 125/6, it is 9 into 125/6, which is 187.50. Hence, adding this and this, we get total is equal to 140.83. Now, according to the new profit, Z new will become 1775 plus 140.83, that is equal to rupees 1915.83. Now let us consider the second case, case 2. Here B1 is equal to 96 minus 90, that is equal to 6, which implies I is equal to 90/13. Therefore, there R1 is equal to 6 divided by 90/13, which is equal to 0.867. Similarly, B2 is equal to 97 minus 120, which is equal to minus 23. Therefore, D2 is equal to 25, which implies R2 is equal to 23/25, which is equal to 0.920. Similarly, we calculate B3, that comes out to be 4. I3 is 150/11. Therefore, R3 will be 4 divided by 150/11, which is equal to 0.293. And hence we calculate the last, that is B4, that is equal to 4, and I4 is equal to infinity, which implies R4 is equal to 15/infinity, and we know that anything by infinity is equivalent to 0, hence it is 0. Now we see that the summation of Ri is 2.080, hence which is greater than 1. Therefore, we are not sure whether the current basis is optimal or not. Not sure if the current basis is optimal or not. This is the answer. Thank you.